2.5 inverses of functions. An inverse is a relationship consisting of the ordered pairs x, y. So we have x, y. The inverse is yx. What happens? They flip. They're inverses. The domain of the inverse is now the range, the domain of the inverse is the range of the original. The range of the original, the y, becomes the domain in the inverse. In the range, the domain becomes the range. They flip them around. We're going to find the inverse of each relation. I have a set of numbers. 1, 2, 2, 4, 3, 6, 4, 8. Is this relationship a function? Why? None of the domains repeat. So, yes, the relationship is a function. What's the inverse of this set? 2, 1, 4, 2, 6, 3, and 8, 4. Is the inverse a function? Do any of the x values, the new x values, repeat? No. So the inverse is a function. Looking at this one. I have 1, 5, 1, 6, 3, 6, 4, 9. Is the original relationship a function? Yes? Why? Are you sure? Well, this one here and this one here are the same. Does it go to the same number? No. So it is not a function. It is not a function for the original relationship. The inverse. The inverse is going to be what? 5, 1, 6, 3, or 6, 1, 6, 3, and 9, 4. It's hard to see that, I know. Is this a function? No. Why not? 6 goes to 1, and 6 goes to 3. So neither of them are functions. Do you understand basic inverses? Do you still understand when it's a function and when it's not? This is nothing really new right here. This is what we're going to be doing. We're going to find an equation that is the inverse of y equals 3x minus 2. What does inverse mean then when we talk about the ordered pairs? The x's became my y's and my y's became my x's. If I want to find the inverse of this, the y's become x's and the x's become y's. To find the inverse, the y's become x's, the x's become y's. Now all I'm going to do is resolve. What do I need to do in order to resolve this one? Plus 2. Add 2, add 2. X plus 2 equals 3y. What's my next step? Divide everything by 3. Divide by 3, divide by 3, divide by 3. And I'm just going to write y equals 1/3 x plus 2/3. This is the inverse of this one. Where did I get the 1/3 from? It's actually 1/3. So I can put x over 3. I'm just going to put 1/3. What do you mean? If you put x over 3 right here, that's the same thing. I just put it out there because a lot of people like to see that number. We just found the inverse. F of x equals 3x minus 2. Looks familiar, right? It's the same thing as y equals 3x minus 2. When we're talking about functions, we're talking about function notation. To write the inverse of a function, I do this. F the negative first power of x. That is called the inverse of f of x. If you see the notation, this right here, right there just means it's the inverse of this. I'm just going to call it g of x here. Find out what fog is. When I do fog, this means I'm going to take g of x and put it into f of x. I'm going to take g of x and put it into f of x. So I have 3 times 1/3 x plus 2/3 minus 2. When I distribute, okay, 3 times 1/3 is just 1, so it's 1x. What's 3 times 2/3? 2 plus 2 minus 2. So it's just x. Find out what GOF is now. Find out what g of f is. For finding GOF, g of f, I'm going to take f and put it into g. So I have 1/3. Now I put in the entire f. 3x minus 2. I still have the plus 2/3. Let's see, 1/3 times 3x is x. 1/3 times negative 2 is negative 2/3 plus 2/3 x. Inverses of one another. If you do the composition both ways, they should both be equal to the same exact thing. They should both be equal to x. That's not 0. This is 0 here. But you still have your x. We're going to graph both of these. The first f of x. F of x is 3x minus 2. If I graph this, down 2, I put my dot. Now I go up 3 over 1. That is my original function. The inverse function we said was 1/3 x plus 2/3. So to graph 1/3 x plus 2/3, I go up 2/3. Now I go up 1 over 3. There's your inverse. For which one? 2/3? 2/3 just means goes up 2/3. Just a little bit. And that's a big mistake. This is not a slope. This is the y-intercept. This tells me where I cross the y-axis at 2/3. It is a common mistake. I just wanted to show you all the graphing aspect. What you're going to have to do most of the time are these. Any questions? All right, let's do another example. I have the function f of x equals 1/3 x minus 1. I want you to find out what the inverse is. All that f of x really means is y. How do I find the inverse? I switch the x and the y. So the x's become y's and the y's become x's. I switched around the variables. Now, I need to solve now for y. What is my first step? Add 1. Add 1. X plus 1 is just x plus 1 equals 1/3 y. How do I get rid of 1/3? Multiply by the reciprocal, which is 3 over 1. Multiply everything by 3 over 1. A lot of people only did one thing by the 3. My answer when I simplify is 3x plus 3. Y equals 3x plus 3, which means the inverse function is 3x plus 3. And that is your answer. All you do is simplify. Yeah, you forgot to take the 3 times the 1. And that's what a lot of people did. Here's another thing. I have the function f of x equals x squared minus 1. As of right now, you don't know how to solve for the inverse. Do you know how to get rid of that x squared? No. So we have a problem. I can find out if the inverse is a function or not. That is a function. I can take in my calculators, turn them on, hit y equals. In y equals, I'm going to type in x squared minus 1. The squared is catty-cornered to the 7. Or I can use the caret above the division and 2. To graph this, so everyone's on the same page as me, I'm going to zoom 6, zoom standard. How can I tell whether or not this is a function? What doesn't hit? The vertical line test. That I knew what you were trying to say. So I take my vertical line. Does it cross more than once? No, it passes the vertical line test. What do you think happens for an inverse? Well, it's the other way. Instead of the vertical line test, it's going to have to pass the horizontal line test. Does this pass the horizontal line test? No. Because it does not pass the horizontal line test, this one is not a function. I can use graphing to determine whether or not something's a function. Vertical line test will tell me if a function is a function, or a relationship is a function. The horizontal line test will tell me if the inverse of that function is a function. Do you understand the horizontal line test? So if you had like x cubed or something like that, you're only used to solving linear equations right now. If you have a quadratic, a cubic, a quartic, whatever, you put it into the calculator, you graph it. Vertically, it's okay. It's horizontally. Will it pass or not? Questions on this section?